Hello, how you doing? We're going to do a video today about the types of numbers there are in mathematics. So let's start with the simplest kind. Natural numbers. Okay, natural numbers are also called counting numbers, and they're usually just listed 1, 2, 3 in a set form, and then 3 dots. It's called an ellipsis, and it means it keeps on going. So those are the counting numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's our first type of number, the first one that man created. They started counting things. So the next type contains the natural numbers. And that's the set 0, 1, 2, 3. So the only additional whole number is 0. 0 is a whole number, but not a natural number. We don't start counting with 0. 0 was added in by merchants who wanted to balance out their accounts. And so the whole numbers include all the natural numbers. That's what this diagram is showing. The next type uses all the whole numbers. Let's put these over here. And their opposites. So the integers include the whole numbers and all the opposites of the whole numbers too. So we'll start with an ellipsis here. Means it goes forever to the left or toward negative infinity. -3, -2, -1, 0, 1, 2, 3, and so on to positive infinity. So it's infinite in both directions. These first two were infinite only toward positive infinity. So then, the next type of number contains the integers. Let's do it like this. And have to be described. These are called the rational numbers. Okay, rational numbers are described as any number A over B, or looks like a fraction, where A and B are integers. Okay? So they include any fraction you can make, including the integers or whole numbers, because you could always put one of these numbers over 1 or divide it by 1 in that form, and it can be written as a rational number. 1 is one of the numbers in the set of integers, so any of these numbers can be represented like a fraction. But they don't have to be. So that's why rational numbers include integers and therefore all of these other ones. Now, attached to but not included in this set of numbers is the irrational numbers. Okay? And there we describe these as well as any real number that is not rational. Okay? And together, this whole group of numbers make what we call the real numbers. Any number on a number line. All the numbers you can find on the number line are either rational or irrational. And then they can be one of these other types as well. So now I want to do a couple of examples of using those notions of the types of numbers. First of all, I want to point out that this is an example of a set written in what we call set builder notation. Set builder notation names the variable being used, x in this case, always has a line after that variable, and we write this vertical line and say such that, or the description for that variable is going to follow that line. So we're talking about all the numbers x such that x is a natural number less than 5. We want to rewrite this. You may be asked to rewrite something like this in another form of set notation. That form is, the form we're going to use here is roster notation. So let's think about the natural numbers. They were the counting numbers that started with 1, 2, 3, 4, 5, 6, 7, 8. Okay, which of those are less than 5? Well, starting with 1 is less than 5, then 2, then 3, and then 4. And there's a roster of the numbers that are described in the initial set. Okay, here's another example of a question you may be asked in the homework. Which of the numbers in the set 5, -2, square root of 9, 0, square root of 5, 3/4 are whole numbers? Remember the whole numbers I described earlier in the video as starting with 0 and counting up. 0, 1, 2, 3, 4, etc. So which of these numbers fit in that set? Well, certainly 0 does. That's one of the answers. And we're not asked to write a set of numbers from this set, just answers, so we're just writing them out. 0 is one of them. 5 is another, but -2 is not, because -2 is, negative numbers are not whole numbers, they're integers. Square root of 9, what is the square root of 9? It's 3. So 3 is a whole number. It's just represented as the square root of 9. So we can write that as representing a whole number, even though it's not calculated completely yet. So we've got 5, square root of 9, 0. We skipped -2 because it was negative. Square root of 5 is not a whole number either because we cannot simplify the square root of 5. And 3/4 is not a whole number either. So these are the three answers that are correct. Here's a couple more examples I want to show to you of problems you'll see. But they depend on knowing this information up here. This symbol that looks like sort of a rounded E means is an element of. Okay? When we put a slash through it like this, then it means is not an element of. And an element means it's in the set or a member of the set. Element's just another word. And we use this Greek letter eta to represent element because it has the sound of E in Greek. So we're going to fill in the blank, insert the correct symbol, either is an element of or is not an element of for these two questions. First one says, is 3, is or is not 3, an element of the set x such that x is an integer? Basically, it's asking if 3 is an integer. And you'd say, yes, it's a whole number with a sign, it's a positive 3. It's even a whole number. So we'd put is an element in that blank. This one is asking, is 8 an element of the set 1, 3, 5, etc.? And when we put this ellipsis here for this one, it means that pattern is continuing the same way. So 1, 3, 5, what would come next? 7, 9, 11, etc. All the odd numbers but 8 is not an odd number. So it is not an element of that set. And there you have it for the video. Thank you.